All right, so this next example is not the perfect setup. It's not the perfect scenario. I want to point that out, so don't copy down what I'm about to write down. If you were to try the same thing as what we did in the last example and just add these together, you're going to get negative 3x plus 4y equals negative 2. That's not helpful. Our goal in using the addition method is to get rid of one of the variables. It's to start with two equations, two unknowns, and end with one equation, one unknown that we can solve. So that's not helpful. So I'm going to erase this and go back to the drawing board. And what we got to think about is that we want our variables from the two different equations to be opposites of one another. So our very first step we want to do is we want to multiply the equation or equations by a variable, or a value that will cause the coefficients of one of the variables to be opposites of each other. So as we're looking at this, we have two options, and neither one's right or wrong. We could make the x's opposites by multiplying the second one by negative 2. That would make them opposites of one another. Or we could look at the y's and say I could multiply the first equation by negative 3, and that would make them opposites of one another. It doesn't matter which one you do. I'm going to go ahead and multiply by negative 2 in the second equation. Now, when I do that, I'm going to rewrite the entire system. Remember, the system stays together right now. So I'm just going to rewrite the first equation. Negative 2x plus y equals 2. And as I distribute the negative 2 across the second equation, I'm going to get positive 2x, negative 6y equals positive 8. Now my x's are opposites of each other. So now we can do what we did in that simple example. Step 2, we want to add the equations together. So let's add. Negative 2x plus 2x is 0. Y plus negative 6y is negative 5y. And 8 plus 2 is 10. Now we can very simply solve this equation. We get y equals negative 2. Now we want to take this value of negative 2 and plug it back into any equation up there. Now, personally, I would kind of keep in mind that my goal is to solve for x, because I already know what y is. So I would look for one of the equations that looks like it's easy to solve for for x. So I'm going to plug back in over here where I have negative x plus 3 times the value of y is negative 2, equals negative 4. And we're just going to solve this equation. Add the 6 to the other side, multiply by negative 1. And so we get an answer of negative 2 for the x, negative 2 for the y. And just like always, it's a good idea to check your answers. In the interest of time, I'm not going to show that, but definitely take the time to check your answers by plugging that x and y back into both equations. And remember that when checking, you have to plug into both equations, not just one or the other. Because if you only plug it into one, all you're saying is this ordered pair is on one of the lines. You need to plug it into both, so you can say it's on both lines, which means it's the intersection.